Okay, welcome to the second lesson of this mini unit. In this lesson, we're going to be talking about how to solve quadratic inequalities and what steps you need to take and how this is somewhat different from solving your regular inequalities. Make sure you have your notebook and a writing utensil out. In your notebook, you want to write down this example problem. Okay, so if I've got 2x squared is less than 6x plus 8. I know I've got a quadratic equation or inequality because I've got an x squared over here. Take a moment and think, what could you do to solve this quadratic inequality? What does your gut instinct tell you to do? Okay, so hopefully since you see that it's a quadratic, when we're solving quadratic equations, normally we try to set this equal to 0. Well, we can't set it equal to 0, but we can set it less than 0. So I want to get everything on one side, everything else on the other. So I'm going to subtract 6x from both sides, subtract 8 from both sides. And that way over here, I'm just going to be left with 0. Less than, I've got a 2x squared minus 6x minus 8. Okay. At this point, what could I try next? Okay. Some of you, again, with the same idea of a quadratic, may have said I can try to factor this out, and we're going to give that a try. So my 2 goes on top, my a. 2 times a negative 8 gives me a negative 16, and I'm adding to a negative 6. Think about what are two values that can fit, that will multiply to a negative 16 and add to a negative 6. You should end up with a negative 8 and a positive 2. I can simplify both of these fractions, so 2 over 2, that's going to leave me with 1 over 1. And 2 over negative 8, that's going to leave me with a 1 over a negative 4. These will both simplify, and the reason why is because you can see that a 2 goes into all three of these. So I could actually divide this whole equation by 2 and this whole side by 2. So whenever I do something to one side of my inequality, I have to do the same thing to the other. So that really I'm just factoring out x squared minus 3x minus 4 is less than 0 divided by 2 is just going to give me 0. So when I factor this out, I'm left with the two binomials, x minus 4 and x plus 1 is less than 0. Okay, so at this point, we're going to think about a big idea rather than having you think about what's going to come next. So you want to ask yourself, what do I do next once I get here? And when you get here, so this is asking, when is this whole quadratic less than 0? So that's what I want to know. I want to know when is the whole quadratic, so x minus 4 times x plus 1, less than or greater than 0. And here's a fact of what you can't do. You cannot factor this out and then separate your two factors. This is what your instinct is going to tell you to do. You're going to say, oh, well, I set x minus 4 less than 0 and x plus 1 less than 0. But you cannot do this. So you're going to try something different. When you have a function, we'll call it f of x. And so f of x can be a quadratic, or it could be a polynomial. So with terms higher than an x squared. And that quadratic or polynomial is set greater than or less than 0. Remember, f of x, and this is going to be key, f of x is equal to my y values. F of x, so my function, gives me my y values. F of x is equal to my y values. So when I have f of x is greater than 0, or when I have f of x is less than 0, what is this really asking? Okay, so if f of x is equal to y, this is really asking, when is y greater than or less than 0? When is y greater than or less than 0? And this is really my y values of my graph. So when I'm answering this inequality, what I really want to ask myself is, when are the y values of that inequality less than 0? When are my y values less than 0? My answers are to this inequality. I'm going to check this graphically. I'm going to set my f of x, so whatever this side is, where I've got my function, equal to y1 in the calculator. In my calculator. And then I'm going to look and see where, in this case, y is less than 0. So let's go ahead and do that. On your screen, you probably want to open up your delta math calculator. And that'll be helpful just to graph this and plot. So go ahead and open that up. Okay, so in my calculator, I've typed in that f of x, so x minus 4 times x plus 1. I could also type in my original quadratic, the x squared minus 3x minus 4. That would also work. I'm going to go ahead and graph this. So again, I want to see where my y values are less than 0. So when I'm looking at this screen, I've got my x-axis and my y-axis. So what I care about right now is where my y values are less than 0. When you're solving this type of problem, it's often helpful just to sketch what this graph looks like on paper so that you can deal with it, because you can't really color on your graphing calculator. So I'm going to sketch a picture of this graph. I've got a parabola, and it's crossing my x-axis at 2 points. I want to figure out what those 2 points are. I'm going to explain how to do that algebraically in a moment, but first graphically, I'm seeing where they cross the x-axis, so where the zeros are to this graph. So I'm going to use the calc feature. I'll go second calc. And then I'm going to look at my zeros. Not an intersection point, because I don't have 2 lines. So I only use intersect when I've got 2 lines, but I'm doing 0. So I'm going to go to the left of that 0. That's good. Oops. To the right. So I've got to change signs. My x has to now become negative. Oh, I made a mistake. Okay, sorry. So second calc, 0. I'm going to go to the left. There we go. To the right. Sorry, my y value is what needs to change signs. Okay, and I get that I've got a 0 at x equals -1. Then I'm going to do the same thing for the other one. Go ahead and do that in your delta math calculator, and you can check back in a second. Okay, you should get that your other 0 is at x equals 4. So why this is important and why those zeros are important is because that's what I'm going to be graphing on my number line. Those are my 2 important values when I'm graphing this equation on my number line. So -1 and a positive. When I ask myself in this graph, where is y less than 0? Well, I'm going to be looking along my y-axis here. So above my origin, this is where y is positive, where all of my positive y values are, or where y is greater than 0. For y less than 0, I'm going to be looking at the bottom half of my y-axis. So my function, I want to see where my function is less than 0. I'm going to shade in this whole part. So the part where my line is in this shaded section, that is where my y values are less than 0. So I'm going to shade in, so anywhere where the line is above the x-axis, then my equation is now greater than 0, so this is not included. My solutions are everywhere in this highlighted section. And you'll notice that that falls in between my x values of negative 1, and my x value of negative 4. So my solutions are everywhere in between those two values. The last thing I've got to ask myself is, are those two values included? So can x equal negative 1 and equal a positive 4? Can my y values equal 0 in my inequality? The answer to that is no, because I don't have this or equal to sign. So I've got open circles at negative 1 and at 4. So using inequality notation, what would my solution be? You should end up with a parentheses, negative 1, comma 4, close parentheses. We're going to solve this one together. We're going to go a little bit quicker. So to solve this inequality, following your instincts, you want to get this set equal to 0. So I'm going to subtract 8 from both sides, so that I end up with 5x squared minus 4x minus 8 is greater than 0. Now at this point you might try to factor this out, but you'll notice that this actually doesn't factor out nicely. I don't have a quadratic that I can factor out because I'm looking for two numbers that multiply to a negative 40 that add to a negative 4, and those two numbers just don't exist. So I'm actually going to leave this exactly like this is, and I'm going to take a look at the graph of it. So in Delta Math at this point, you're going to type this function into your y1 and see what this graph looks like. Okay, so I've typed this whole equation into my y1. I'm going to graph it. Okay, so I've got this nice parabola. I'm going to sketch that onto my paper just so that I can visualize what this graph looks like while I'm solving. So it's kind of a narrower parabola than the first example. It looks something like this. I want to figure out what my two zeros of that graph are. Go ahead and calculate what are those two zeros of my parabola. Your two zeros, you're going to end up with two decimals, and that's fine. So the first zero is at negative 0.927. The second one is at 1.727. So at this point, this time I'm looking at where is my function greater than 0. So where is f of x greater than 0? And whenever I see f of x, I want to think, where are my y values greater than 0? So if my y values are greater than 0, I'm looking along my y-axis. Well, my greater than 0 part is everything above the origin. So it's this whole section of my graph. Okay, so it's excluding, if I think about where it's not equal to 0, the x values in between these two. Well, that's where my graph is less than 0. So let's go ahead and graph this on a number line right below. The two values that I care about are negative 0.927 and 1.727. Because they cannot equal 0, again I'm going to put open circles at both of these values. Now I want to think about my shading, and this one's a little bit trickier. So it's actually not the values that are in between these two. So if it's not in between, that means that it has to be the values on either side. Has to be the values on either side. So you want to ask yourself, am I looking in between the two values, or am I looking outside? And since I'm not looking in between, it's going to be going outside. Go ahead and write your solution in interval notation. Okay, so you should end up here. So you're starting over at negative infinity, going to negative 0.927, both get parentheses. Then you've got a break, so you put a u. Then you're going from 1.727 all the way to infinity. And solve these three for you. Once you finish, you can put away your notebooks. We're going to come and practice with these tomorrow, just checking our solutions graphically with our graphing calculators on Friday.